So today is May 1st. This is Aaron Murakami out of Spokane, Washington. And we have Eric Dollard on the call with us. And we don't have a specific schedule of anything we want to talk about. We'll just be going over some basic announcements. Let's see, I'm going to go ahead and mute everybody out except for Eric. Just give me a second to do that. Okay, so pretty much everybody is muted out. Can you hear me okay, Eric?
Yeah, I can hear you fine.
Okay, so today is May 1st. We have Eric Dollard live on the call, and we'll just go over a couple basic announcements. First of all, is there anything that you want to announce?
No, everything's pretty much the same here.
Okay. Last night I was a guest on Coast to Coast AM radio with Richard Serrett, and that was a good opportunity to be able to at least get some exposure to a lot of our network and the conference, and was able to mention your name, Eric, a few times. Hopefully that will get some traffic coming to the site and help with donations and book sales. And that was a pretty fun experience. We have the 2016 Energy Science and Technology Conference coming up on July 8, 9, and 10, which is a 3-day event, Friday, Saturday, and Sunday in Hayden, Idaho, which is about a 50-minute drive from the Spokane, Washington airport. And Eric Dollard will be giving probably a 4.5 hour presentation or so on Friday. And so if the seats are really running out right now, especially after last night's radio show. So there are a handful of seats. If you do want to come, you can go to energyscienceconference.com, fill out the registration, and then submit the payment right away, and that'll lock your seat in. We've probably got about 25 seats left, and with about 2 months to go, it's definitely going to be completely sold out. Right now, Eric, is you're back at the lab, and we're spending a little bit of time in Lone Pine and up in Fallon, and so I guess we can just go ahead and open up for questions, or nothing you want to report right now, or?
Yeah, let's just see what people have to say.
Okay, and first of all, I do want to mention Eric's website is ericpdollard.com, P for his middle name, Paul. So ericpdollard.com, in the right column, if you want to support Eric's work and EPD Labs Incorporated, it is a 501c3 nonprofit registered in Nevada. So any donations are tax deductible. You can either make a donation through PayPal or send check or money order to the address in the right column there. You can help support the work. We'll go ahead and open up for questions. And so if you do have a question, hit 5*, and I'll put a little flag next to your phone number, and I will unmute you, and you can ask your question. So you have an opportunity to pick Eric's brain pretty much on anything that you want. So go ahead and hit 5*. Okay, so if your phone number is ending in 7114, I'm going to lower your hand and unmute you. Go ahead and introduce yourself and where you're from, and go ahead and ask your question.
Yeah, hi, this is Scott Mefford in Denver, Colorado, and I'd like to have a quick overview of Eric's work and how electronics hobbyists would have the best opportunity to get involved and where we should start.
Did you hear that, Eric?
It was a little garbled. I didn't quite get it. Did you hear it?
Yeah, kind of what's a good route to go starting off as an electronics hobbyist? Is that kind of it, Scott? You can go ahead and repeat it if you're able to speak up a little bit and make sure Eric gets it all.
Yeah, okay. I'm not sure why it's not coming through very well, but in any case, I would like to have a brief overview of Eric's work and how electronics hobbyists can contribute.
Okay, I got it that time.
Okay.
Well, I don't know how I could give a brief overview of my work because I wouldn't know where to start because I'm involved in so many things. As far as the electronic hobbyist goes, I would try to concentrate on the world of electronics before World War II and duplicate a lot of the experiments that were going on back then, like with regenerative receivers and little transmitters and various things to make yourself familiar with that type of technology, I would not waste my time with integrated circuits or microchips or software or any of that kind of stuff. That will just get you nowhere. So the important thing is to experiment, is to get various vacuum tubes and transistors and condensers and resistors and what have you, and start building your own amplifiers and oscillators and become familiar with how to move around in that medium and become creative in it.
Thank you. That sounds like a great idea.
The best educational material available in the field of electronics is the educational, the educational curriculum provided by the Navy to its electronics technicians. So if you can get a hold of any Navy electronics courses, particularly older ones from the 60s, that would be very helpful because their explanations are usually accurate. And everything is very clear, and also I would recommend getting a hold of any Navy electronics books or some of the earlier Bell Telephone Company books if you can find them. Unfortunately, most of the stuff has been pulled off the library shelves and dumped. So that kind of makes getting a hold of this material difficult, but it is around, and you probably can track some of it down. And if you go through all my videos and presentations and what have you and writings, particularly on the energetic forum, there's usually loads of references.
Okay, so that sounds like a good foundation. But as you said, that's already been around since the 60s or so. So once we get that under our belt, then where do we take it from there in the context of your work?
Well, I mean, that's kind of up to you. And then the thing is I've really left electronics and gone back to electricity. So the electron theory really is not much use in what I'm working on. So then you would have to go back to the earlier electrical works from around the turn of the century in 1900. And Kenley and Steinmetz are usually your main guys there. One thing that you're going to need is you're going to have to become very good at dealing with algebra. So I would recommend beginning with some courses on algebra so that you can understand what it is that you'll be encountering in these books. So training yourself in algebra and experimenting with it and applying it to simple Ohm's law situations and become familiar with maneuvering the variables and parameters around, as well as becoming familiar with handling resistors and capacitors and doing various electrical experiments, particularly early wireless experiments from 1900 to 1915 can be very educational. If you can find any of those books, even like titles like the Boys book on electricity and what have you, become familiar with building your own capacitors, coils, and all that kind of stuff. That'll also be very helpful. Do not expect immediate results. You know, you're going to have to put at least several years into this before you can become creative in the medium, because there's a lot of material to absorb. And the earlier you start in age is better. I started at age 6, so that kind of gave me a head start. And it was in an era where society was very favorable to this stuff. So I received quite an exotic education as a child, which is no longer available to anybody on this planet.
Okay, well, thank you very much for those ideas.
Okay.
Now, Eric, you're mentioning the regenerative receiver, like the Armstrong regenerative receiver. Would you recommend the Amateur Radio's Handbook? And if so, from like what year would be a good one? Because since that has a lot of those basics.
Yeah, the earlier Amateur Radio handbooks, and also the monthly magazine that came out along with that called QST, particularly the QSTs before World War II. Will have all kinds of fascinating experiments and build your own stuff. And I find that the best Radio Amateur's Handbook, and the one that I used when I was a child, was the 1960 Radio Amateur's Handbook. for me, mainly because the references that it contained in the back part is I was able to find the pin diagrams for all the exotic World War II radar tubes and crazy things I was getting from the surplus store so that I could hook them up and make them operate. So I use the 1960 Red Amateur's Handbook, but it's kind of your preference as to what era you want to gravitate on. But the eras surrounding World War II, both before, during, and after, really is the heyday of electronics. As far as electrical experimentation goes, is all that stuff pretty much ended by 1915. So you'll have to go back, like I say, from around 1900, 1910, 1915 in that area for the electrical stuff, that build your own this and build your own that. And it seems like there's ample materials on eBay. I'm still able to find stuff that I thought would vanish from the face of the earth forever. So you'll probably be able to find all the old tubes and things you need to duplicate these early radio experiments and electrical experiments.
Yeah, the amateur radio.
Hey, thanks again. Fantastic suggestions. And it's funny to hear the Morse code in the background as we're talking about the radio stuff.
Oh, yeah, there is always Morse code in my world, 24 hours a day.
So, yeah, Scott, if you check eBay, they usually have old copies of the Amateur Radio Handbook. And Eric mentioned that Boy's Book of Electricity. If you search in Google for Boy's Book of Electricity, you can come across the PDF. And that actually has a lot of those circuits and schematics on it that Eric is talking about.
All right. Yeah, that sounds great.
So let's see. Okay, thanks, Scott. Okay, if your phone number ends in 0014, I'm going to lower your hand here and unmute you. Go ahead and introduce yourself and where you're from, and you can go ahead and ask your questions.
Hello, Eric and Aaron. This is Garrett Aziz. I'm in California. Let's see. Eric, I sent you a few letters, a general delivery about 6 months ago. We're talking about electromagnetic motors and overseas utility projects. And my emphasis is in power as well, electricity, just like you. And I'd like to thank you and Aaron both for compiling the quadratic representation of electricity and the packages therein. And you brought up the wireless energy, so I wanted to ask you, in an ideal world for Professor Dollard, what are the next steps? Are we going to upgrade this horrible infrastructure of transmission of power lines, or do we have something between wireless? Should we go directly to wireless? In your ideal world, where should we go?
Well, in today's world, the Tesla idea of wireless power transmission is not really practical because of the gluttony for electricity. It would probably cause a massive series of earthquakes and destroy the world. So I think that's kind of out of the question.
Okay.
The basic three-phase, three-wire transmission line and the two-pole DC transmission line really are excellent mediums for carrying electricity. It's become quite practical and functional. Unfortunately, what's going on is utility companies seem to be retrograding their electrical systems to produce some really undesirable configurations. Most notably is the double Y connection with the common neutral, which is turning the electrical power grid into a giant EMP receiving antenna, and the grid and distribution system is configured in such a way that this is all delivered to the customer full power. So if Kim Il-suk decides to lob a nuclear bomb over the United States, it seems like the utility companies are opening their arms wide to it and channeling it right into the customer. It's kind of not clear exactly why this is coming about. The utility companies are very obstinate about it. It's costing them a fortune to take their three-phase, three-wire systems and convert them to four-wire, multiple-grounded, Y-connected systems. So it could be just social insanity, or it could be a conspiratorial plot. could just be complete stupidity. But as for someone that's been in transmission engineering as long as I have, and coming from 2 previous generations of it, the whole thing to me is appalling.
Absolutely. Could I just ask a little more detailed clarifying question on the subject? In regards to transmission lines, obviously you know better than anybody else, there's considerable resistance when we're going through the copper wire. The quadratic poles are going above, beyond, between, around the wires. So can we create some sort of medium better than the transmission wires that we're using today? Or is it solely in the configurations that you're speaking of for reduction of resistance over transmission?
Well, I mean, the efficiencies are quite high, and the extra high voltage DC transmission system has really proven itself. There's no reactance problems there, and the resistance of the conductors is really negligible. So it works. It seems to be cost effective for the utility companies. It's reliable. It's relatively safe. The distribution systems, they have to, of course, be alternating current. They're being rendered unsafe. Basically, the only alternative is to produce your own electricity. There should be on every rooftop of every building and house and whatever United States should have a complete array of solar panels. That's the only sensible way to deal with the situation, and try to produce as much of the electricity as possible locally and not rely on external sources of electricity. One complication with solar panels, which is also a similar complication in the extra high voltage DC transmission systems, in the process of converting from DC to AC, a large quantity of harmonics are produced, and the AC that comes out is not very desirable. Also, making the grid digital and using electronic devices in the place of electrical devices is just begging for catastrophe. And unfortunately, all these advanced solar systems are just filled with microchips and harmonic generating silicon control rectifiers, and so there's really no escape of some kind of negative element being involved with the utilization of electricity with the technology as it exists today.
Thank you.
Okay. Do you have any other questions, or?
I'm sure I'll come up with a few more throughout this. Thank you both very much.
Okay, you're welcome.
Okay, let's see. If anybody wants to ask a question, just hit 5*, and that'll put a little symbol next to your phone number, and I'll know you want to ask a question. We don't have a whole lot of people on the call today, so, okay, yeah, if your number ends in 7088, you're already unmuted. Go ahead and introduce yourself and where you're from, and go ahead and ask your question.
Hi, my name is Ed Becknell, and I'm from Covington, Louisiana. I'm the energy advisor for Michael Tellinger's Ubuntu Liberation Movement. And one of the most primary things that the goals of our movement is to find alternative energy sources to free people from centralized control of energy, of electricity. And I've been following your work, Eric, and as well as Aaron. I just purchased your book, Aaron, The Quantum Key, and it's very nice, very good work. Really like it. So some things I've looked at include some of John Bedini's work, the Bedini, and as well as Hope Girl's QEG, and as well as Edwin Gray with some of the patents that he has on these devices that are based on Tesla hairpin circuitry that creates like longitudinal waves to get over unity. Do you have any advice or any direction that you could offer to guide me in the right direction, and so I don't waste a lot of time on useless technology?
Well, unfortunately, most of the things he mentions will just keep you running in a circle and you won't get anywhere. So no one's moving beyond. Billions of dollars has been wasted on free energy research, and it doesn't produce any free energy. I view it as a dead horse. I did have my own ideas on how to approach the situation with something called parameter variation. There was a video done a long time back in association with Borderland Sciences that showed a rotating transformer that produced parametric variation of inductance that had a remarkable efficiency, which actually measured over 100%. So I would recommend research into that area. I had engaged somebody to carry out one aspect of this research for me of something that's called the magnetic amplifier, which is a device that allows for a parametric inductance variation. It seemed to hold promise for energy synthesis, but unfortunately the guy ran off with all the money, and so I just dumped the project. My interest, if I could push anything forward in a research project, is to figure out how to separate the hydrogen and oxygen in water, overcome the molecular binding force without the absorption of energy. It's been rumored that people have done this.
I'd like the geek, Paul Pantone.
Personally, that say they have done it. What was that? I talked over you.
I'm sorry. One of those devices that I've looked into is Paul Pantone's Geek, G-E-E-T. I'm not sure if you're familiar with that.
Yeah, I'm familiar with Paul Pantone. He has a bad reputation in my neighborhood, which can lead to some rather exotic stories, which are kind of not in the scope of this question and answer thing, but it did make quite a show in the town. You have to start scratching this stuff. The people that have been making all these claims have been running a dog and pony show in this regard now for 30 years, and then you just have to decide at what point do you call it 1 over E, and that's that, and that the horse is dead, and it's not going to move no matter what you inject it with or how hard you kick it. So everyone is really on their own. Right now, Siemens is constructing a number of very large hydrogen-burning electrical power plants in Germany. They are interested in the concept of separating the hydrogen and oxygen without the absorption of energy. They surely have the brain power and the manpower to pursue such a thing, but the elemental idea does not seem to be out there yet. So Aaron and I have accumulated a quantity of equipment, or components, I should say, to build equipment to begin research in this area kind of blindly, just to jump into to one thing and give it a try and see how it works out. But the thing is there's so many other things going on and what have you that is finding the time to devote to any extraneous project from the ones like for me, I'm working on the telluric wave transmission and all that kind of stuff. And Aaron has all his business he's got to operate. I don't know if we'll get to it, but the ideas are there and the parts are there. So the person that told me, I knew a Bell telephone engineer who was a good friend of mine in Landers, who unfortunately got killed in a flash flood. He had some rather fantastic ideas that I don't know if he got from the secret Bell telephone laboratory here or if he came up with on his own. He was kind of a hysterical character, but his claim was that he simply took a switching power supply and took the square wave output, which was about 30 kilocycles, stepped it up with the transformer, and then applied it to some screens configured like a capacitor in distilled water, and he claims that the hydrogen and oxygen came readily apart with without any significant absorption of energy. So that's a starting point. I don't know if he made up a fish story or if it was real or what the deal is, but that's where I would start with. He pointed out the complication involved is when you separate the hydrogen and oxygen from water, there's a balance between them, and if you combust them, then they turn back in the water, but they also do not create a compression wave. So it doesn't really operate the engine properly. So what he had to do was involve some other researchers that were working on nanotechnology to develop seeds that would separate the hydrogen from the oxygen, molecular seeds, and then have regulator valves to properly control their combination in the internal combustion engine. So that's about as much as I know about it, but I guess that's a better starting point than none.
Okay, thank you.
Your name is Ed, you said?
Yes. Ed Beckman.
So on emediapress.com, our main publishing site, we just put the almost full catalog on that homepage. But on emediapress.com, if you scroll down to the, I believe it's last year's conferences, the 2015 conference videos, the discussion or the panel discussion moderated by Gene Manning, that's embedded on that page. And if you watch that, there's, I don't know, maybe 20, 30 minutes of discussion on this type of separation of water, which is like, I guess you could say like electrostatic tug of war on a water molecule and ripping it apart, versus running current through it like in an regular electrolysis cell. And so Eric has some more comments on that, and a couple other people do too. And if you send me an email, I can give you some references to some of the other stuff that you mentioned.
Okay, thank you.
Okay, thanks, Ed. Let's see. Okay, one person has their hand raised. I'm going to go ahead and lower your hand. You'll hear a little recording. And then I'm going to unmute you. Go ahead and introduce yourself, where you're from, and go ahead and ask your questions.
Hi, Eric. Hi, Aaron. This is Michael from Australia again. And
Students.
I have students, that's right. Thanks, Eric. I have just a general statement, and that is about the Tesla coil in whatever sort of geometric form you will find it in, and that you have basically that the output end of a Tesla coil is not the top terminal capacity where you have all those sparks, flying off. It's actually the other end, or the neutral end, or the grounded end of the secondary. It's really the output, or your caloric output, if you will, or whatever. And basically the rate of change of the dielectric fields gives rise to that displacement currently that is utilized. So I think that's one of the very simplest things in your work that you point out that is helpful to most Tesla coil experimenters, is to realize that fact. Have you got anything more to add to that?
Yeah, well, that's kind of what Tesla tried to point out over and over again when he talked about his transmission system, but nobody seemed to get it. And then what confuses the matter is Tesla also used the electrostatic end of the thing to do his basic plasma experiments and particle rays and all the Crookes type stuff and what have you. So that tends to create the fallacy that that's the output of the Tesla transformer. You do not want any sparks or anything like that on the high voltage end of the transformer, because that just basically is like a short circuit. So the biggest engineering difficulty in building a Tesla transformer for transmission into the earth is to prevent the fire from breaking out at the high potential terminal at the other end of the transformer. The other major obstacle is a grounding system that has a very low quantity of resistance and inductance. In other words, it has an extremely low impedance. That impedance has to be at least 100 times less than the transmission impedance of the coil, which means about one or 2 ohms maximum. That's a very difficult engineering feat for the experimenter, because we're talking about like 80 wires 100 feet long and 32 ground rods around the periphery of it. And even then, in certain geological conditions, that might not really get you into the ground. So those are your two biggest obstacles: is no fire for the coil and no impedance between the bottom coil and earth, which means that the transformer really has to sit right on the ground system.
Yeah, right. Yeah, that's the difficult part, I suppose, and difficult to engineer, but I'm sure someone can come up with something somewhere on the planet.
Well, the thing is, if you can get the cooperation of an AM broadcast station who already has that ground electrode and share their ground, then there's a possibility to do those kind of experiments. There are a lot of defunct AM broadcasting stations, or at least in America, where the ground electrodes are still present, and you can use those if you want to try any large-scale experiments. Otherwise, if you stick with very small transformers and higher frequencies, then the ground requirements aren't quite as severe, because the wavelengths are shorter. Everything contracts down to a smaller size, and the impedance of the coil tends to rise because it tends to have more turns, and it's more confined rather than low-frequency coils, which are really big and don't have a lot of turns but have a lot of diameter. So it's a kind of a complicated give and take engineering situation. But I think with whatever writing or videos that I've produced so far, I think it's pretty elementary how to go about it, and it's just basically a matter of mechanics at this point.
Yeah, sure. Well, that's what I'm probably working with, the smaller system, to get that working in some regard. And, once you do get it working, and then how to actually put it into practical use, like can we transmit some data, to one device to another, through the ground, and, or some sort of coded, message or something through the ground, so that we can convey some intelligence from one thing to another through the single wire, or the single medium of the earth.
Yeah, I've been getting letters from people that are already doing this in the 160 meter amateur band. That's about 1,800 kilocycles, and they're having really good success. And I had good success in the past on the 80 meter and 40 meter amateur radio bands. So you do have to get a license, otherwise, you'll get in trouble, particularly in any country that's derived from the United Kingdom, which is very restrictive when it comes to radio type stuff. So be careful not to get yourself in trouble when you're doing this.
Yeah, sure. On stepping back a little bit, you talked about parametric variation, and I've noticed some devices online. There's such thing as a parametric wobbler. It kind of uses a high-speed motor on a capacitor, sort of ham radio type equipment. But if you run an experiment with the parametric variation, you mentioned the variation with inductance, but I was looking at the variation with capacity, trying to come up with some sort of high-speed variable capacitor, such as Chris Carson did back in the day. Is there any what do you see as the major difference between variation of capacity versus variation of inductance with respect to time?
I think the capacitance might be, in theory, might be a better approach, but variation inductance is easier because you can use core saturation. But I would venture to say that any system that would synthesize energy, if such a thing is even possible, we'll probably have to use both.
Right.
In other words, the dielectric field and the magnetic field will have to be in some kind of parametric variation with some kind of phase angle between them. So that's what seemed to indicate itself in the magnetic amplifier experiments, but those were not completed, so it's not conclusive yet as to exactly what's going on. I don't know if that information ever made it out on the internet or not. The person that I had referred to was a pathological hoarder of both material and information, and I just could not get his cooperation to put this stuff out on the air so other people could duplicate it. And right now, like I say, I've had to drop it because I've got so many things going right now, particularly the book I'm writing and getting ready for this presentation. Not alone all the maintenance things and other stuff that I have to do that I think if I got one more thing to do, it'll make me go insane. So I have to start load shedding. So the energy thing has been dumped as far as I'm concerned. But I'm always willing to advise people that are attempting this. So anybody that does experiments can, write me a letter and send their diagrams and what have you, and I'd be more than happy to help them.
Sure. Yeah, so I'm constructing a letter as I'm just going to print off some photos and then I should be able to send it off. One of the things I've included in it, I've got here, and you spoke about it last time, it's to do with silver, the element of silver. And one of the things
But what? Now I didn't quite get that. The what? Element
of silver, like the metal silver.
Oh, silver. Silver?
Yeah.
Yeah, silver.
Oh, okay. Yeah, silver and its interesting photoelectric properties.
Yes. One of the things I've done is I've made a little silver refining cell, and that's where you've got like some unpurified silver at the top, which is an anode and a filter, and then you've got sort of a cathode at the bottom, and a solution or the electrolyte is made of concentrated silver nitrate, which is, you can use, it turns black if your fingers touch it. But it's interesting, you get these little pure silver crystals that grow on the cathode, and they look like organic little tree roots or almost like an electrical discharge that grows up from the cathode. And in the solution of water, of the silver nitrate, you can almost see these little swirls or little lines of force that come down and the crystals tend to grow into them. It's really a weird sort of process to watch. So I've taken some photos of them and I'll send them to you, as well as a little selection of the crystals, and you can have a look at them yourself. But in there you can almost see what you talk about, the tubes of force in the liquid almost going down to the crystals. So that's just one of the things on the side I thought I'd tell you, and I'll send these little crystals to you so you can have a look yourself.
Okay, yeah, it sounds interesting. I don't know, what I can say about it, but at any rate, it's important to experiment and keep seeing these things, even if there's no explanation for it. That's no reason not to do it, because it demands an explanation, and then, like you're saying, it could connect to the J.J. Thomson tubes of force theory. Chemistry is not my forte, but nevertheless, I know the basics about it and what have you. So these type of formations, and apparently some of this stuff also is these particular formations that occur when solutions are crystallizing are affected by planetary configurations and solar flares and what have you. So what might happen in one interval of time may not exactly happen in another interval of time. I think there was some early Borderland publications about that, where solutions were allowed to crystallize during planetary alignments, and different elements seemed to correspond to different planets in a way that the ancients had attributed the element and planet correlation, which turned out to be interesting. Needless to say, that's not something that modern science would approve of, but if it works, it works. That's the way I look at it. I'm an engineer, not an academician.
Right. Yeah, these crystals, they do, from one batch to the next, they do have seem to be a little bit different in some ways. I don't know why exactly yet. One of the other questions I had is on the electric universe people keep talking about something called a Birkeland current, or, that was, I suppose, named after Birkeland. But what is your understanding of a Birkeland current?
That's something I've never heard of. You might have to give me a little bit of background on that. You say it's a current?
They call it a Birkeland current. It's like a current between one, like a star or something, towards another planet, or interstellar currents or lines of force.
Okay, yeah. So it's a interstellar current. So is it a conduction current or is it a displacement current? It's probably a conduction current, but what do they attribute it to be? Is it associated with particles, or is it something associated with the ether? Do they say anything about that?
Well, they don't really determine whether it's ether or particles. I imagine that's probably thinking in terms of normal concepts of electricity, so they probably think it's particles. But it seems to be a current that spirals around itself, so it's a very narrow sort of beam almost. But I don't know too much about it, but I'll see if I can dig up some more information, perhaps send it to you and see what you can come up with about it.
Yeah, it sounds interesting. So I guess you could say I'm a promoter of the electric universe theory, even though the people that utilize that name, I don't have much interaction with them, but to me, particularly from my RCA days in studying the ionosphere and what have you, it's the whole universe is alive with electricity, and I would regard that as the prime mover of everything that's going on in the universe, particularly from the results of my experiments in the Marconi building with the Tesla transformers and producing cosmic formations and burned-out light bulbs. That pretty much solidly convinced me at that point that creation is an electrical process. And then I think my last presentation kind of reestablished that idea also.
Well, I think that's absolutely true, that there is, the electric universe is a theory or that sort of thing, probably also coupled or made better understood by your work. In fact, it's probably the next frontier in science, but we shall see, I suppose.
Yeah, well, I mean, like I said, this stuff, I saw it on the laboratory bench. So at that point, it starts to become less theory and more fact when you actually witness this stuff occurring on the laboratory bench that occurs on a stellar level, yet the biggest particle accelerators built by the academians and scientists here on Earth can't duplicate these things. Yet they have, 220 kilovolt three-phase power lines that run in and feed these things, and I was running my device off of just a very simple dryer outlet.
Oh, okay. Another thing, how are you going with your LMD network devices for the conference, or your longitudinal magneto?
Right now I'm just I'm immersed in the preparatory mathematics, so I'm in the process of deriving all the equations and relationships that are going to be needed to quantify these other types of electrical waves. So it's all in a very primordial state right now of transmission line equations and impedances and admittances and propagation constants and all that kind of stuff. And I'm barely seeing the light at the end of the tunnel. So I can't say a lot about it right now, and I don't know exactly what it's going to turn into. Time's running out. But I manage to plug away on it every day, and whatever comes out of the presentation, I'm sure will be worthwhile. I don't know if I can fill in a full 4 hours this time or not, but it always seems to pull itself together in the end. Unfortunately, the forest that I live in before the presentation to finalize and write all this stuff burned down. So I no longer have a place to live to do that. So we'll see. I don't know.
All right, Eric, I'll let someone else ask you questions. So thanks for your time,
Okay.
and good luck with your conference.
Okay.
Hey, Michael?
Thank you. Welcome.
Thank you.
Hey, Michael, can you hear me okay?
Yeah, sure.
Hey, so for those of you on the call who don't know, Michael from Australia goes by Spootins on Energetic Forum, which is energeticforum.com, and he's one of the more advanced builders who's been in this for a long time and has shared quite a bit of his work on Energetic Forum. And if you want to see some of that, you can go to ericpdollard.com, and in the menu bar, there's a link for Forum, Forum. And if you click on that, you can see a couple links in there to some old archive discussions. And the most recent one, I believe there's a link to like part 3, which says open for discussion. And if you go in there and look for Spootins, you can kind of see some of the work and some of his contributions in there. You know, and a lot of times people like to hear from other builders and people replicating, you know, some of this kind of work, you know, what they would advise, you know, experimenters getting started, you know, to get started. Do you have any advice for beginners in what direction to go, like, you know, possibly, you know, Crystal Radio Initiative and Lone Pine Writings or something like that? That's, you know, at the basic levels. What would you recommend?
Well, I would recommend, and this is what I did, is just get a hold of an old ham radio book. There's a lot of Eric's work is directly related to ham radio. So go and get yourself a ham radio handbook and just start reading it and you know, build a small transmitter, because that's what you'll be using to run your coils. You know, stick with a low power thing so you don't upset the radio people, and just learn all about it through ham radio books. I think that's the best thing to do, as well as build your coils, and as Eric has stated, and you'll have some success.
Right. Now, the ham radio book, are you talking about like even the modern book which teaches people how to get their ham license or their basic license, or?
No, I bought like a 1973 one, and or the earlier ones that have vacuum tube information, and also, you know, some of those middle ground ones also have covered the same thing in transistors. So I would go for an early sort of version, the 1950s through to about the 1970s ham radio book. AARL, is it?
Yeah, American Radio Relay League.
Yeah, that's right. And so that's what I found helpful. If a bit just practically building things and learning the terminology and all that sort of thing.
Right. And for anybody who's not in the ham radio, and you know, myself, I'm not a ham radio operator, and I don't have a license. But when Eric mentions you do have to have a license for some of these things, or you can get in trouble. If you search, I believe in Amazon, you can get the most recent edition of the ARRL ham radio guide. I'm not sure what the whole title is, but ARRL, American Radio Relay League. They have a manual that you can study, and I've looked through it. It's actually fairly simple, but you do get some of the basic electronics and vocabulary to kind of give you the schema for some of this radio stuff. And a lot of different towns will have their own little ham radio clubs where some of the old hams will actually be the ones conducting the tests. And so search for that ARRL if you are interested in getting a ham radio license, because you know, that's required for some of the stuff that Eric was talking about. Well, thanks for that, Michael. I'm going to leave you unmuted, and at any time on this call, if you want to chime in on anything, go ahead. Okay. I'll go ahead and let's see. If your number is ending 0014, I'm not sure if we opened it up for you yet, but if your number ends in 0014, I'm lowering your hand and unmuting you. Go ahead and introduce yourself and go ahead and ask your question.
Yes, this is Garrett again. I asked a question earlier. My question now is in regards to the sun, our transformer, and based on Eric's extensive work and research previously with that, and I'm sure he's still very much up to date on that, as well as harmonic frequencies within the Earth. Is there any new information, pertinent information you'd like to share of the current state of the sun and the Earth and the frequencies therein? Thank you.
Well, the only thing I can say is this particular solar cycle has been dismal. It hasn't really produced much of an output. And now it's going into its dead phase over the next 4 years. The solar flux will keep diminishing until it reaches a minimum, which could end up being a record level minimum, which will in turn have some kind of effect on the climate. In the past, situations like this have usually caused it to get colder, but every solar cycle seems to be quite unique, and it's difficult to attribute the results of one to the expected results of another. One thing about this particular phase of the solar cycle that we're in now, the decreasing or waning phase, is the solar eruptions that do occur contain more mass ejections, which in turn induce large magnetic fields and electric currents into the Earth, which then in turn increases the earthquake and volcano activity. But most of these events have been so weak that see anything really, how would you say, absolutely remarkable happening out of this, but you don't know. You have to watch. So this last wave of earthquakes that started in Japan and propagated down to Ecuador seemed to be a little stronger than normal, and it was associated with the solar flare. So that spot should be coming around the 15th of this month. So you might want to mark your calendars and see if this particular hole in the sun is going to have also a reoccurring earthquake cycle on Earth. So this is kind of part of the interesting part of the study, is to wait and see these correlations. So I've got it marked in my log. In the past, there have been extensive correlations between solar flares and earthquake activity. I got a chart on the wall here of 1 year's graph readouts at Landers, and it definitely shows that solar flares and earthquakes have a relationship, but there doesn't have to be a solar flare for there to be an earthquake. So it's not a completely worked out process, but it's something that you can study if you can figure out a way anymore to get the solar information. I think the stuff's available on the internet, but the internet has convoluted it all to the point where it's hard to get anything basic out of it. There are some ham radio websites that get into regular discussion about the sun, but a lot of these people really are more interested in talking about themselves than talking about the sun, so you just have to wade through the mire. What I've done for decades, recently I haven't been able to do it because I haven't been able to get radio reception in my situation of confinement here, but a good way to get started on this is to graph the solar flux on a daily basis and keep up on that and have the graph paper hanging on the wall and look at the variations and then correlate those variations with what you see the weather doing outside and the reports that you hear of earthquakes, and then you can make your own determination, and that's basically what I did at Sonoma State, along with having these very exotic RCA HF receivers that allowed me to study the ionosphere at the same time. So if you're in a wide enough area where you can get on the short wave band and listen to the shortwave receiver during the intervals of sunrise and sunset, those intervals will always produce some kind of unique modulation on the stations and kind of serve as your voltmeter or what have you of how the sun's affecting the ionosphere. And it's not really complicated to do a lot of that stuff as long as you're in an area that's not inundated by electrical noise. And if you can wade through the mire of the internet and find the information you want to produce your own graphs. I would recommend doing it the old way, like I do it on graph paper with a pen, point to point. And stay away from anything digital if you can, because all digital does is obscure things and make it abstract, and impairs the researcher's ability to gain a full understanding of what's going on.
That was immensely helpful. Oh, go ahead, Aaron. Thank you.
Eric, what is that exact solar flux reference?
Well, it's called the 10.7 centimeter solar flux. In other words, it's a microwave frequency of 10.7 centimeters wavelength. I think it's 2,800 megacycles. And there's an observatory in a place called Pentacon, Canada, that basically derives that information on a daily basis, and then it's transmitted on the National Bureau of Standards HF station called WWV, both from Colorado and Hawaii. I don't know what's going on with those people. It's kind of the same little queek mentality that's infecting everybody in this country, is they deliberately distort the information and they don't repeat the numbers twice, and they're doing everything they can to make it difficult to get this information. But that's how I derive it, is off of my shortwave radio, the PRC-47 in the car, and they'll give you a number called the solar flux every day, and that by definition is the watts per square centimeter received on Earth from the sun at a frequency of 2,800 megacycles, and that wattage multiplied by 10 to the minus 22 power, which means that that's a very small quantity of power. Obviously, they have big dishes to make it more than 1 square centimeter, so they can get a response. You can use your own antennas and noise receivers and whatever, and point them at the sun at noon and measure the noise voltage on your receiver every day for those people that, that have that technology, that can either find microwave receivers and microwave antennas or build them. I was doing that at Landers with a batch of these point-to-point antennas the water departments and what have you used on the 950 megacycle band for controlling remote pumping stations and what have you. I had a very large array of those antennas. They were Yagis, and I made a big network of them, big square with about 20 of these things in an area spaced, and connected that to a old World War II radar countermeasures search receiver, and that actually worked for getting a rough idea what the solar flux is doing, and then you can see the surges and peaks. There are methods that you can adapt telescopes also so that you can look at the sun and see the sunspots. I know Steve McGreevy does that, and when I'm in the neighborhood, usually I go over to visit him, and we can take a look and see what the actual images are in the sun. I think a lot of this stuff is available on the Internet. If you search and can pin it down to what you want, you don't really need a lot of equipment. But it's always better to do it yourself, because then it's part of reality rather than some abstract page that you're getting off of a computer screen.
Yeah, and Garrett, if you search Google for the 10.7 centimeter solar flux, a couple websites will graph that out, so you can go back and look at the history of what it does and all the cycles and stuff. Do you have any other questions, Garrett?
I do. Thank you. I've got another one, and thank you both very much for that detailed answer, and I'm absolutely going to start documenting the solar flux daily and observing nature, so that's beautiful. Thank you. My next question, I've been experimenting for a number of years, just playing around with pulling, basically earth batteries, pulling amperage from the earth. I've been able to get around as much as a third of an amp and as high as a little bit over 1 volt per cell within the earth. And I've done varying cement cells and crystalline power cells and everything therein. My question was,
Do you have any suggestions, or, I mean, basically it's not really feasible for everybody to have a quarter acre, half acre, 1 acre of rods in the earth. Have you read any technical papers from the early 1900s on cement batteries? And that's sort of what I've been doing with right now.
No, I don't know anything about that at all, but there's, I've heard about these things. I think there's a guy named Nathan Stubblefield that worked in this area and had gotten significant quantities of electricity. I don't really know how it comes about, but I would like to know. So if you or anybody else can find any detailed information that gives something quantitative, I'd really like to see it. It could have applications in advanced seismic warning or studying earth currents, or it's not clear exactly how this current and electromotive force is derived out of the ground. It doesn't seem to be by electrolysis, otherwise the materials would eat themselves up, but I don't know anything about it, but I sure want to know more about it.
Well, I'll make sure to print out the technical papers from the 1920s that I have from one researcher on the cement batteries. He's not specifically pulling from the earth itself. He's creating individual cells, but it is entirely applicable to that process, because whether it's from the earth rod within the earth or a cell sitting above the earth, there's still that field, the unseen field that it is pulling from, and it never short circuits. Never ever short circuits. Runs out.
Okay, well, it sounds interesting. Something to look into.
Well, hey, on this reference to Nathan Stubblefield, I just grabbed a book off my shelf. This is probably the most comprehensive book that's been published on Stubblefield. You can find his old patents in the patent databases, but you might find this book interesting, called Kentucky Farmer Invents Wireless Telephone, But Was It Radio? It's the facts and folklore about Nathan Stubblefield, and it's by Bob Lochte. I'm not sure how it's pronounced, but it's Bob. Last name is Lochte, and this is kind of a history of Nathan Stubblefield. And if you want one of these books, Eric, let me know, and I'll get a copy sent to you. But Garrett, you can find this on Amazon. I think that's where I bought it. But yeah, Kentucky Farmer Invents Wireless Telephone. That's the name of the book on Stubblefield.
Thank you so much.
These earth batteries. Hey, any other questions, Garrett? Or
not at this moment. Thank you both.
Okay, thanks, Garrett. Hey, I was wondering, Eric, you're going into some of the solar cycles and some of the natural earth cycles. You want to take maybe a couple minutes and explain what the tide log is, and how that relates to some of these cycles, and how you use that book in your study on these natural cycles?
Well, the tide log basically is convenient for me. It used to be published out of Bolinas, so it was something that was readily available at one time, but from what I understand, Commonweal ran them out of Bolinas, and they're, like everybody else, including me, and they're in Georgia now. To me, it's useful because it's something that sits in my car, and then every day I can write down frequencies I find. I can write the solar flux down. It shows me when there's going to be planetary alignments, major planetary alignments, so I know beforehand that those things are going to occur. But the salient factor of the tide log is that it shows the tides graphically, like sine waves, and it really gives you a better understanding of how all that moves. So even if you're not living next to the ocean or whatever, these forces still exert themselves on the planet. And it's interesting to go through the tide log and see how the various relationships between the moon and the sun produce these interesting complex waveforms that constitute the tides, and how there's like yearly cycles and quarterly cycles. And so it's a way to get a better grasp on the reality of nature around you in a form that's not abstract, but is something that you can physically see. You can see where the moon's at, you can see where the sun's at, you can see the curvatures of the tides, the rate at which they convert from high to low and low to high, the harmonics, whether they're second harmonics or third harmonics. It really helps put you in touch with what's going on dynamically around you on the planet Earth.
Yeah, and the tide log, if anybody goes to tidelog.com, that's TIDELOG.com, the regions that they cover is along the some of the U.S. and Canadian East Coast and West Coast, from the south all the way up to the north. And I don't know, it's about $15 or something like that for one of these tide books, but you can go to tidelog.com and order one for, whichever one is closest to you, if you're in the United States or Canada. Let's see. Okay, if anybody has a question, go ahead and hit 5-star. We're going on an hour and 8 minutes right now. We should probably wrap it up here in about maybe 15 minutes or so. So if you have a question, go ahead and hit 5-star. That'll put a little symbol next to your phone number, and I can go ahead and open it up for you to ask a question. We got another question from Garrett. Let me go ahead and unmute you, Garrett, and yeah, go for it.
Thank you. Eric, if money wasn't the option and a nefarious individual was not running away with the money, you had a good partner, what are some of your top primary projects? I know you said you really want to get into, you feel people need to work with the electrolysis, the hydrogen-oxygen, and obviously you've been doing the frequencies of the Earth and so on. So what are some of your passion projects if money wasn't an option?
So I have to complete what I started here with this advanced seismic warning system and the telluric transmission and reception project. So we are committed to completing that project. It was supposed to be done by the end of last year, and it wasn't. There's been nothing but one mishap after another to prevent any forward movement. Right now, the major obstacle is getting the money to construct the terminal building into the entrance of the mine where we have our seismographs and along our open wire right away for our antennas and transmission lines and what have you. That's going to be probably about $80,000 to build that. And then we need about $10,000 to bore the holes in the earth to put the capacitance electrodes down in to receive out of. We do have all the insulators, cross arms, and wire and what have you for the overground part. So assuming that there isn't any more disruption, I hope we can start that in September and at least get the aerial wiring and networks and all that stuff installed by the end of this year. But there won't be anything to connect it to. So it'll just have to be test instruments out in the field. We have another site. We need to negotiate a lease with the owners of a mountaintop microwave site to put in the companion station, the stereo aspect of it. So we have two of these things so that we can steer in on where the signals are coming from. But right now that's outside of the projected funding. Attempting to get $250,000 to wrap this thing up here, including making the final payment on the building and get rid of these monthly payments, which are real bloodletting. So that's all I can think about right now is completing what I started. I have saved up enough of my Social Security money that I think I can start making some kind of progress to get the basic benches and outlets in here, so I have something that you might approximately call a laboratory. I've got piles and piles of stuff that either has to be stripped or discarded. I do have some help with that coming up here, so I'm hoping by the end of the summer that a lot of equipment was purchased in the past about 15 months by somebody that were referred to as the patron. And we're very anxious to get this equipment up on the benches and plugged in and have one bench for the networks, another bench for dismantling, a third bench for radio repair, and a fourth bench for metalworking, and so on down the line, so that I can start doing something here other than confining myself to the sound room and writing, which is about all I can really do here, but that's better than nothing. So I spend about 8 hours a day on that. We have to complete our technical facilities here, which means that we have to build our terminal facility. We have to build and or lease pairs from the phone company to get the signals from the terminal facility here into the main building. We have to build a central office here in the main building that houses the chart recorders and what have you, and sends the signals out to the agencies that want to share the information. That's one aspect. The second aspect is to have a construction and experimental type of setup here where I can start building the equipment that's supposed to go on the racks for what I previously described. And then the third complication is getting the publication, getting the material that I've written published. If there was an infinitude of money, then this place would be outfitted to be a complete laboratory. There's quite a bit of equipment here all ready to do it. And then an attempt would be made to find all the necessary alternating current instruments, meters, relays, what have you, and transformers to start doing research in the polyphase power and what this thing is that the power company's trying to pull and exactly what's going on with that, and then possibly some parameter variation, mag amp type stuff and what have you. But at age 64, I'm kind of getting burned out on all this stuff, and I really don't have anybody to help me. The people that in the past have shown up to help usually just end up embezzling the money or screwing stuff up, so I don't know exactly how to go about that. One idea I did have was to kind of farm this stuff out and maybe set up some alternate facilities up in Spokane where people could experiment and then I could remotely direct them, and then that way this labor could be spread out. But it all costs lots of money. So basically the entirety of my Social Security is consumed in just moving forward here at a snail's pace, and then bills are paid for and what have you by other people. The net sum is about $3,000 a month, and the best I can produce out of it is writing. So I suppose that's better than nothing. Otherwise, we wouldn't even be talking on the phone right now.
Thank you. Thank you for that, Eric. Now, the three projects will be completed. They absolutely will. I know you're much more of a realist, but they will be completed. Now let's jump 1 year, year and a half, 2 years down the line. Everything's completed. You have teams administering the projects. You're directing. What's the next steps for you?
Well, I'll cross that bridge when I come to it.
Okay, very good. Thank you, Eric. Thank you, Aaron.
Okay.
Hey, thanks, Garrett. Let's see. We have time for maybe one or two more quick questions before we wrap it up. If anybody has a question, just hit 5-star, and I'll unmute you, and you can ask your question. We're going on an hour, 20 minutes now, so let's wrap up in 10 minutes or less here. So if you have a question, go ahead and hit 5-star. If nobody has a question, I'll go ahead and mention again that, in July 8, 9, and 10 will be the 2016 Energy Science and Technology Conference, and Eric Dollard will be presenting there. And you can get details for that at EnergyScienceConference.com. There's only 20-something seats left, and with about 2 months to go, they're all definitely going to be sold out. So if you're going to get a chance to come up and hang out with Eric up at the conference and see his presentation live and get to meet the rest of the speakers, I'd recommend definitely registering and submitting payment pretty quick. we do limit it to 150 people, and that's because of the size of the venue. It really is kind of small, but that gives everybody a chance to have a lot of good, intimate time with the speakers and get to pick their brains, sit back, have a drink with them, and that kind of thing. It's real laid-back, casual atmosphere, and so we hope to see some of you at the conference. And also, Eric's website is ericpdollard.com. And on there in the right column, you can make a donation to support Eric's work and EPD Labs Incorporated, which is a 501c3 nonprofit corporation. And you can donate by PayPal or send checks or money orders to the address in that column there. And if you want to write Eric directly, he'll almost always write you back at his Lone Pine address. There's a Lone Pine General Delivery address on there. And that's where you can send letters, and Eric will write you back. Can you think of anything else, Eric, before we wrap it up, if nobody else has a question?
Yeah, I think that's it.
Okay. Well, sounds good. I guess we'll go ahead and wrap it up then. Thank you, Eric, for your time, and I'll talk to you here soon. And thank you, everybody, for being on the call. And and this call is recorded, and so I'll put this on a YouTube video. My YouTube channel is Aaron Murakami, all one word, just my first and last name. And if you scroll through the history of my videos, you can see the other live calls that we recorded with Eric. We're going to try to do these kind of somewhat on a regular basis, depending on whenever Eric's schedule and my schedule matches up, and we can do this. And on ericpdollard.com, if you join his mailing list, or even if you're on Energy Times or any of our other newsletters, you'll get a notice when we will be doing these. So I guess with that, okay, enjoy everybody. Thank you so much, and I'll get this up on YouTube here shortly, within a couple days. Take care, everybody. Thank you. Thanks, Eric.
Thank you.
Okay. Until next time. Or software, or any of that kind of stuff. That will just get you nowhere. So the important thing is to experiment, is to get various vacuum tubes and transistors and condensers and resistors and what have you, and start building your own amplifiers and oscillators, and become familiar with how to move around in that medium and become creative in it.
Thank you. That sounds like a great idea.
The best educational material available in the field of electronics is the educational, or would I say, the educational curriculum provided by the Navy to its electronics technicians. So if you can get a hold of any Navy electronics courses, particularly older ones from the 60s, that would be very helpful, because their explanations are usually accurate. And everything is very clear, and also I would recommend getting a hold of any Navy electronics books or some of the earlier Bell Telephone Company books, if you can find them. Unfortunately, most of the stuff has been pulled off the library shelves and dumped. So that kind of makes getting a hold of this material difficult, but it is around, and you probably can track some of it down. And if you go through all my videos and presentations and what have you and writings, particularly on the Energetic Forum, there's usually loads of references.
Okay, so that sounds like a good foundation. But as you said, that's already been around since the 60s or so. So once we get that under our belt, then where do we take it from there in the context of your work?
Well, I mean, that's kind of up to you. And then the thing is I've really left electronics and gone back to electricity. So the electron theory really is not much use in what I'm working on. So then you would have to go back to the earlier electrical works from around the turn of the century in 1900. And Kenley and Steinmetz are usually your main guys there. One thing that you're going to need is you're going to have to become very good at dealing with algebra. So I would recommend beginning with some courses on algebra so that you can understand what it is that you'll be encountering in these books. So training yourself in algebra and experimenting with it and applying it to simple Ohm's law situations, and become familiar with maneuvering the variables and parameters around, as well as becoming familiar with handling resistors and capacitors, and doing various electrical experiments, particularly early wireless experiments from 1900 to 1915 can be very educational. If you can find any of those books, even like titles like the Boys' book on electricity and what have you, become familiar with building your own capacitors, coils, and all that kind of stuff. That'll also be very helpful. Do not expect immediate results. You know, you're going to have to put at least several years into this before you can become creative in the medium, because there's a lot of material to absorb. And the earlier you start in age is better. I started at age 6, so that kind of gave me a head start. And it was in an era where society was very favorable to this stuff. So I received quite an exotic education as a child, which is no longer available to anybody on this planet.
Okay, well, thank you very much for those ideas.
Okay.
Now, Eric, you're mentioning the regenerative receiver, like the Armstrong regenerative receiver. Would you recommend the Amateur Radio's Handbook? And if so, from like what year would be a good one? Because since that has a lot of those basics.
Yeah, the earlier Amateur Radio handbooks, and also the monthly magazine that came out along with that called QST, particularly the QSTs before World War II. Will have all kinds of fascinating experiments and build your own stuff. And I find that the best Radio Amateur's Handbook, and the one that I used when I was a child, was the 1960 Radio Amateur's Handbook. For me, mainly because the references that it contained in the back part is I was able to find the pin diagrams for all the exotic World War II radar tubes and crazy things I was getting from the surplus store, so that I could hook them up and make them operate. So I use the 1960 Radio Amateur's Handbook, but it's kind of your preference as to what era you want to gravitate on. But the era surrounding World War II, both before, during, and after, really is the heyday of electronics. As far as electrical experimentation goes, is all that stuff pretty much ended by 1915. So you'll have to go back, like I say, from around 1900, 1910, 1915 in that area for the electrical stuff, you know, that build your own this and build your own that. And it seems like there's ample materials on eBay. I'm still able to find stuff that I thought would vanish from the face of the earth forever. So you'll probably be able to find all the old tubes and things you need to duplicate these early radio experiments and electrical experiments.
Yeah, the Amateur Radio Handbook.
Thanks again. Fantastic suggestions. And it's funny to hear the Morse code in the background as we're talking about the radio stuff.
Oh, yeah, there is always Morse code in my world, 24 hours a day.
So, yeah, Scott, if you check eBay, they usually have old copies of the Amateur Radio Handbook. And Eric mentioned that Boys' Book of Electricity. If you search in Google for Boys' Book of Electricity, you can come across the PDF. And that actually has a lot of those circuits and schematics on it that Eric is talking about.
All right. Yeah, that sounds great.
So, let's see. Okay, thanks, Scott. Okay, if your phone number ends in 0014, I'm going to lower your hand here and unmute you. Go ahead and introduce yourself and where you're from, and you can go ahead and ask your questions.
Hello, Eric and Aaron. This is Garrett Aziz. I'm in California. Let's see. Eric, I sent you a few letters, a general delivery about 6 months ago. We're talking about electromagnetic motors and overseas utility projects. And my emphasis is in power as well, electricity just like you. And I'd like to thank you and Aaron both for compiling the quadratic representation of electricity and the packages therein. and you brought up the wireless energy, so I wanted to ask you, in an ideal world for Professor Dollard,
it is a 501c3 nonprofit registered in Nevada, so any donations are tax deductible. You can either make a donation through PayPal or send check or money order to the address in the right column there. You can help support the work. We'll go ahead and open up for questions. And so if you do have a question, hit 5*, and I'll put a little flag next to your phone number, and I will unmute you, and you can ask your question. So you have an opportunity to pick Eric's brain pretty much on anything that you want. So go ahead and hit 5*. Okay, so if your phone number is ending in 7114, I'm going to lower your hand and unmute you. Go ahead and introduce yourself and where you're from, and go ahead and ask your question.
Yeah, hi, this is Scott Mefford in Denver, Colorado, and I'd like to have a quick overview of Eric's work and how electronics hobbyists would have the best opportunity to get involved and where we should start.
Did you hear that, Eric?
It was a little garbled. I didn't quite get it. Did you hear it?
Yeah, kind of what's a good route to go starting off as an electronics hobbyist? Is that kind of it, Scott? You can go ahead and repeat it if you're able to speak up a little bit and make sure Eric gets it all.
Yeah, okay. I'm not sure why it's not coming through very well, but in any case, I would like to have a brief overview of Eric's work and how electronics hobbyists can contribute.
Okay, I got it that time.
Okay.
Well, I don't know how I could give a brief overview of my work because I wouldn't know where to start because I'm involved in so many things. As far as the electronic hobbyist goes, I would try to concentrate on the world of electronics before World War II and duplicate a lot of the experiments that were going on back then, like with regenerative receivers and little transmitters and various things. To make yourself familiar with that type of technology, I would not waste my time with integrated circuits or microchips.
So today is May 1st. This is Aaron Murakami out of Spokane, Washington. And we have Eric Dollard on the call with us. And we don't have a specific schedule of anything we want to talk about. We'll just be going over some basic announcements. Let's see, I'm going to go ahead and mute everybody out except for Eric. Just give me a second to do that. Okay, so pretty much everybody is muted out. Can you hear me okay, Eric?
Yeah, I can hear you fine.
Okay, so today is May 1st. We have Eric Dollard live on the call, and we'll just go over a couple basic announcements. First of all, is there anything that you want to announce?
No, everything's pretty much the same here.
Okay. Last night I was a guest on Coast to Coast AM radio with Richard Serrett, and that was a good opportunity to be able to at least get some exposure to a lot of our network and the conference, and was able to mention your name, Eric, a few times. Hopefully that will get some traffic coming to the site and help with donations and book sales. And that was a pretty fun experience. We have the 2016 Energy Science and Technology Conference coming up on July 8, 9, and 10, which is a 3-day event, Friday, Saturday, and Sunday in Hayden, Idaho, which is about a 50-minute drive from the Spokane, Washington airport. And Eric Dollard will be giving probably a 4.5 hour presentation or so on Friday. And so if the seats are really running out right now, especially after last night's radio show. So there are a handful of seats. If you do want to come, you can go to EnergyScienceConference.com, fill out the registration, and then submit the payment right away, and that'll lock your seat in. We've probably got about 25 seats left, and with about 2 months to go, it's definitely going to be completely sold out. Right now, Eric, is you're back at the lab, and we're spending a little bit of time in Lone Pine and up in Fallon, and so I guess we can you want to just go ahead and open up for questions, or nothing you want to report right now, or?
Yeah, let's just see what people have to say.
Okay. And first of all, I do want to mention Eric's website is ericpdollard.com, P for his middle name, Paul. So ericpdollard.com in the right column. If you want to support Eric's work and EPD Labs Incorporated,